Welcome to The Explainer. Today, we're diving headfirst into a layered fortress approach for the brand new CompTIA A Core 2 version 15 exam. Specifically, we are zeroing in on Domain 2 security. Whether you're aiming to land a killer IT support role or you just want to absolutely bulletproof your own digital life, we're going to figure out how to build a digital fortress together, literally layer by layer.
Okay, let's dive into this. Here's our roadmap for the day. First, unlocking Domain 2 security. Second, physical and logical defenses. Third, securing the network perimeter. Fourth, malware and system vulnerabilities. Fifth, the human element. And finally, number 6, device and browser hardening.
All right, Section 1, Unlocking Domain 2 Security.
So the IT landscape has shifted pretty dramatically recently. And Domain 2 security, well, it now accounts for a massive 28% of the new Core 2 V15 exam. And since you need a strict passing score of 700 out of 900, this mathematically becomes the single most critical area for you to conquer. It's really no longer just some niche topic. It is absolutely the core of modern IT support.
Moving on to Section 2, Physical and Logical Defenses.
And this brilliantly illustrates our outer defenses. On the left, we've got our physical outer walls. Think of physical security as the hardware stopping actual physical bodies. We're talking fences, man-traps, and bollards, those heavy concrete cylinders that literally stop trucks from ramming into a building. Then, on the right, we have logical security. These are your digital gatekeepers. They operate on concepts like the principle of least privilege, which means giving users only the exact permissions they need to do their job, nothing more. And privileged access management, which completely locks down those super user administrator accounts so they can't be abused.
Now, all of this builds into one of the absolute most vital concepts of the V15 exam, which is zero trust. Back in the old days, if you were inside the building, the network just inherently trusted you. Well, not anymore. Zero trust is a brand new, major V15 topic, meaning your fortress now checks IDs at every single inner door, regardless of whether you're already sitting inside the network or accessing it from a random coffee shop.
So how do we actually check those IDs? We use the multifactor authentication, or MFA, matrix. To properly verify identities at the gate, you absolutely must combine different factors from this table. And heads up, combining 2 passwords? That doesn't count. That's just 2 things you know. To truly lock down an account, you have to combine something you know, like a PIN, with something you have, like an authenticator app generating a time-based code on your phone, or something you are, like facial recognition or a fingerprint.
All right, Section 3, Securing the Network Perimeter.
Now, in a big enterprise environment, we rely on centralized authentication servers. These operate on the AAA framework, which stands for Authentication, Authorization, and Accounting. For standard wireless and VPN access, you'll often see Radius acting as the main gatekeeper. If you're managing Cisco router access, you might use TACAS+. But inside a Microsoft Windows domain, Kerberos is king. So, the crucial point here is that Kerberos basically acts like a digital valet. You log in once, it hands you a special service ticket, and you use that ticket to seamlessly access all other network resources. A really slick process known as single sign-on.
But what about smaller perimeters, right? Like a remote worker's home office. Securing a SOHO network is absolutely paramount. You have to change those default administrative passwords on routers, use the modern WPA3 standard for wireless encryption, and definitely disable UPnP, or Universal Plug-and-Play, to stop rogue devices from just randomly opening firewall ports. Oh, and if you have a web server that has to be exposed to the public internet, you fence it off in a demilitarized zone, or DMZ, so it stays totally separated from your safe internal network.
Moving right along to Section 4, Malware and System Vulnerabilities.
When attackers actually breach the perimeter, they use a whole variety of common malware threats. Ransomware maliciously encrypts your data until you pay up. A Trojan tricks the user by hiding malicious code right inside a legitimate-looking download. A PUP is a potentially unwanted program, usually just annoying bundled junkware. But that third one on the list, a zero-day, that is the ultimate IT nightmare. A zero-day is a vulnerability actively being exploited before the software publisher even knows about it or creates a patch. There is literally zero time to prepare.
So what happens when an infection actually breaches your walls? For the performance-based questions or PBQs on the exam, you have to know the exact emergency procedure. The very first action you take is always isolate the infected system. Disconnect it from the network right away to prevent the infection from spreading like wildfire.
Then, while antivirus quarantines the known files, the best practice is to basically nuke it from orbit by completely re-imaging the machine to guarantee it's perfectly clean. Finally, the absolute last step is to educate the end user so they don't, click that bad link again.
Okay, Section 5, the human element.
Think about all the bollards, the encryption, the zero-trust architecture, and the heavy-duty firewalls we just set up. Despite all of that, what do you think is the single greatest vulnerability in your entire digital fortress?
It's human psychology. Social engineering manipulates people into bypassing the security for the attacker. Let's look at this visual dictionary real quick. Phishing uses spoofed emails to steal credentials. Vishing attacks happen over a voice call. Smishing attacks arrive via SMS text messages. Spear phishing highly targets a specific individual, like an executive. And actually, highly relevant for the new V15 exam is QR code phishing, where attackers paste malicious matrix barcodes over legitimate ones, tricking users into scanning them with their phones and just handing over their passwords. Crazy, right?
Now, what's really fascinating here is how an evil twin attack exploits human trust in public spaces. Imagine you're at a coffee shop and you see two Wi-Fi networks broadcasting the exact same shop name. One is locked, one is open. If you connect to the open one just to save time, you might actually be connecting directly to an attacker's rogue access point sitting right next to you. They act as the middleman, silently intercepting all your data while you sip your latte.
Last but not least, Section 6, Device and Browser Hardening.
For mobile endpoints, Mobile Device Management, or MDM, is the ultimate administrative control for corporate-owned devices. An MDM console allows IT to push security policies over the air, prevent users from sideloading unapproved third-party apps, and, most importantly, it can execute a remote wipe. So if an employee accidentally leaves their smartphone in the back of a taxi, the IT admin can remotely vaporize all that corporate data before it falls into the wrong hands. It's a real game changer.
And for our laptops and external drives, we use encryption. BitLocker provides full disk encryption for Windows OS drives. But definitely don't forget BitLocker to Go, which specifically encrypts removable USB flash drives. The beauty of full disk encryption is that even if an attacker completely bypasses your physical security, steals a laptop, and pulls the physical hard drive out of the machine, the data remains an absolute, unreadable puzzle without the correct decryption credentials.
Finally, we absolutely must harden the web browser. Because, let's face it, it's the most used application on any computer today. You can verify software downloads are legitimate by checking developer hashes like SHA-256. In corporate environments, you'll configure proxy servers to actively filter out malicious web content. And pay super close attention to these critical V15 additions, enabling secure DNS, which encrypts DNS queries to prevent snooping, and implementing endpoint detection and response, or EDR. EDR uses modern behavioral analysis to hunt threats in real time right on the machine.
Which leaves us with this final thought. If a highly sophisticated attacker manages to drive past your physical bollards, socially engineer your MFA codes, and completely evade your EDR software, is your human firewall trained well enough to spot the trap? The technology is truly only as strong as the people using it. Keep this layered fortress mindset front and center, and you'll be well on your way to absolutely crushing Domain 2. Thanks for joining me on this explainer.